So we're still in section 10.4 where we're talking about determinants of matrices, square matrices. So how do you handle it if it's a 3 by 3 or even higher? How do you do a 4 by 4, a 5 by 5, a 6 by 6? Because if you get bigger and bigger systems, then you're going to actually need to use these determinants. Definitely a better method as I'll show you in the next section. Kramer's rule is much better than having to do the inverse matricing method. But you've got to know how to do determinants. So that's what I'm going to be showing you here. So this technique for the 3 by 3, there's a shortcut that I will also show you. But the shortcut only works for 3 by 3s is the problem. So I'm going to show you the longer way for 3 by 3s because this is the method you will use to apply to 3 by 3s or 4 by 4s or 5 by 5s and so forth. Okay? So here's how this works. It's called expansion by minors. And what you do is you pick any row or column. And typically, students will pick, when they first start doing this, they will just pick the top row to use. Okay? But, so basically what you do is you start off, you're looking at this top row. And when I want to find the determinant of this, so the determinant of 2, -1, 3. I guess to be formal, I should write out the determinant like this. If I'm starting off, if I'm going to use this row, then what I'm going to break this down into is 2, first number, times its minor. Its minor is going to be a 2 by 2. So if you're wondering like how much space to leave, you've got to leave enough for a 2 by 2 inside those determinant bars. Okay? And then it is minus, but the next number is a -1. So it's minus and it's a -1. So this alternates. It starts off, the first one is positive, the second one is minus, -1 times its minor, so I have to leave room for a 2 by 2 in there. The next number is the 3, so it's plus 3 times its minor, which also is going to be a 2 by 2. So see, when you're looking at these 9 elements up here, think of this like kind of like a checkerboard pattern. For these 9 elements that I have in here, since I chose the top row, this is what I chose here. I chose the top row to use to do my expansion. So the first one is positive, that's why this is a +2. Minus, that's why I'm subtracting the second one. Plus, I'm adding the third one. We could have chosen the middle row, for example, and instead of using this top row, and I could have done 1, 4, and 4. But when I did that, it would be -1 plus 4 minus 4 times their minors. Okay? If I did the bottom row, 1, 0, 2, I'd have +1 minus 0 times its minor plus 2 times its minor. And you can actually, you don't have to use rows, you could use columns. You could take the first column instead and do the 2, 1, 1. To do 2, that's a positive, minus 1 times its minor plus 1 times its minor. All right? There's lots of options, and we're going to have a discussion about why would I want to choose a different row. Okay? But like I said, most of the time, students learn this, they're just like, I'm just going to use the top row. And that's what they do to begin with. But sometimes you can save yourself time, and we'll talk about this in a few minutes, by using a different row or a different column. But I haven't talked about how to find the minor yet, okay? So I need to put in a 2 by 2 inside here with this 2. So there's a reason why I have these 2 meter sticks here, and that is because the minor of a number, here's the 2, so I'll do it right here. Here's the 2 that I'm using. What you do is you eliminate its row and its column. So you eliminate the numbers that are in the row and column of that number for that 2, and you see what 4 numbers are left? 4, 4, 0, 2. That's what goes here, 4, 4, 0, 2. So then I want the -1's minor, so if you eliminate its row and column, you'll see you have 1, 4, 1, 2 left. That's what goes in here, 1, 4, 1, 2. And then 3's minor is 1, 4, 1, 0. If you do this correctly, no matter what row or column you choose, the final answer will come out to be the same. Okay? which might blow your mind a little bit because you'll be like, I use something different. And yes, no matter what, the determinant will come out to be the same. So, for right now, here I've got 2, and then I need to figure out its minor. So this is a 2 by 2, so this is what we just did. You're taking 4 times 2, which is 8, minus 0 times 4, which is 0, so that minor turns out to be a value of 8. Here I've got minus a negative 1, so I'm just going to change that to plus 1 times its minor. So this minor, 1 times 2 is 2, minus 1 times 4 is 4, 2 minus 4 is a negative 2. Moving on to the last one, plus 3 times its minor. 1 times 0 is 0, minus 1 times 4 is 4, so that comes out to be a negative 4. I'm obviously showing a lot more work than you really have to, but here I get 16, and then I've got minus 2, and then I've got minus 12, and so it looks like that answer comes out to be 2. So when you find a determinant, it is just going to be a single number for an answer, okay? It's going to be some sort of integer value, assuming these are all integers, okay? So if your numbers start off as integers here and you do your minor, you're going to get that same value. So here's the question. Is there a row or a column that would have been better for me to choose? In this case, not so much, but let's say that I picked, let me back up again, and I'll start over again, 2, negative 1, 3, 1, 4, 4, 1, 0, 2. Had I chosen this row, for example, I'd have 1 times its minor, and then I'd have minus 0 times its minor, and then I'd have plus 2 times its minor. So that means this middle one I wouldn't even have to do because it has a 0 there. So I'd be down to just calculating 2 minors instead of 3. Doesn't seem like that big of a deal here, but when you get to bigger problems, it might actually turn out to save you some time. And I will be using that technique as we go through other examples.